tribot is a tribot with two wheels powered by a large motor and a metal ball in the back for steering. Our design is very durable and reliable, and we barely ever have to change it for attachments or different missions. We use two medium motors to control a front arm and a top arm. We used a color sensor, two of them, to follow, sense, and stop at a certain point in a line. We use the gyro sensor to make accurate turns and to drive straight. We use the ultrasonic sensor to stop at a certain distance away from the wall.
We have many different attachments to complete our missions. We have a front bumper that helps us push other attachments. We use an attachment called hammer time to complete escape velocity. We have space travel and slip and all array attachment that we use at the same time to push space travel while it on the slip rail. We have a cradle for the space station mission, and we have a rover for cradle crossing.
We try to be strategic on what missions we picked. First, we looked to see if they were easy or hard. Second, how many points they were. And third, how close they were to base. We also try to use the same attachment for different missions. We combine individual missions in the same run at the same time.
Once we picked our mission, we would plan it out before we started programming. First, we would walk an imaginary robot through the actual board. Then, we would talk to our coaches about it. And then finally, we would make a flow chart. This flow chart would help us plan ahead of time on what we wanted the program to do and what attachments we might need to build.
We used a lot more sensors this year, and we also added two new ones, the gyro sensor and the ultrasonic. The gyro sensor allowed us to have very accurate turns, and the color sensor allowed us to find, follow, and square up to black lines. These two sensors have really helped us accurately move across the board. Some missions we found were easily completed by simply driving along the edge of the wall. We found that we either used the walls or the lines on the board to accurately navigate. We found that as we learned more, we could do more complicated programs. We used the MathBox tool to help utilize commands and variables, and this came in handy when we were using the gyro sensor and the color sensor. We also used MyBlocks, which Braden will talk more about.
For our complicated coding, we use MyBlocks. The first MyBlock we used is the square up. The square up allows both color sensors to find the edge of a line. The second MyBlock we used is the line follower, which uses a continuous reflective light intensity reading to adjust the power between the two motors and keep the sensor over the edge of the line. This will allow us to know exactly where a robot was for missions far away from base. The third MyBlock we used is the gyro straight. The gyro straight makes the robot go straight forward and correct any drifting the robot does. The gyro straight works by adding more power to a motor based upon the reading of the gyro sensor. And the last MyBlock we used is the gyro turn. The gyro turn is a turning program that is used to make sure the robot turns a set amount.
Before we would say a program was finished and move on to a different program, we would run it 5 times. The program would need to work 5 times in a row before we would call it finished. If the robot did not work 5 times in a row, we would work to improve the accuracy. If it was a programming issue, we would figure out where it went wrong and change it. And if it was a hardware issue, we'd modify the robot.
Ton of time left for us to ask you guys plenty of questions. I love that you added in a bunch of sensors, and this is the first time I've been hearing of the gyro sensor, but you explained it great. And I had a question about the wall sensor. What sensor allows you to know where you are in position to the wall? Which one was that again? Yeah.
The ultrasonic.
All right. How does that work?
So pretty much, for example, so this is the ultrasonic right here. Let's say you're driving up towards the wall. Once you get to a set distance, it'll say, hey, we're at this distance, do what's next. When you're following a wall, usually what we use is we follow a wall until we find a black line, and so therefore we can tell it.
So does the sensor allow your robot to know where it is and allow it to complete multiple missions? Because you said you had the ability to run multiple missions at once.
Yes, it does allow us to find where it is.
Cool.
For an example, if we find a certain black line, we know we're at that exact black line.
So what are the missions you chose?
We chose escape velocity, the satellite one, which gets that into here, crater crossing,
space travel,
Street production, extraction, and
Gerhard, and observatory. A lot.
Do you guys have quite a lot of success with all those, or is it on and off depending on which ones you choose?
We complete the missions about 80 to 90% of the time.
So, you might have, programs for every mission. Did you use your code, reuse your code, between the missions, or you completely?
Sometimes we'll reuse our red followers from
Sorry,
previous
say-
years. Sometimes we'll reuse our red followers from previous years.
Okay. Okay. And you have your code here?
Oh, yeah, the code's right here.
Yeah, that most part.
So tell me a little bit about how you went about building robot. Did you guys decide, let's do these missions first, or let's do these missions and we will build our robot accordingly, or did you build the robot first and then adapt towards missions?
We decided which missions we wanted to do, and then we built the robot accordingly.
Because we pretty much use the same design every year. We do very less changes. For example, this year we added a front bumper to help with other missions. But usually we use a lot of mechanical designs. As you can see, we got all this.
Can you show off some of your attachments?
Yeah, so we have this one, which is called hammer time. So what it does is it goes against a wall, and when it gets over the instant velocity mission, this arm is pushed by the thing right here, and the arm comes out, and it drops this little block, which slams this, and this will go all the way up there.
It's a weighted brick, so it's bigger than.
It's weight, yeah. And then, would somebody like to show up another one?
We also have a cradle right there, which houses the, I guess, cone for one of the space station missions.
We have this, which we have this one from the robot.
And
Just the rod, the board, and this stuff.
And what that arm does, this
This one?
yeah.
Gee, why don't you explain?
What was it?
It would go in the drop, and then once it would,
So as it comes across here, Tina, you can hold it down. So as it comes across, this arm gets pushed out by the mid thing, and that falls down.
and it's under a foot if you added in another weighted brick on top
Because
of.
we read through the rules and said all attachments have to be under a foot.
which is
Just barely under.
apparently.
Love the name, hammer time. That's great. What's the one with 4 wheels on it?
That's a rover for the crater crossing.
Britton, do you want to explain the rover?
Okay, so what this rover does is the robot uses pretty much just an average arm
Just the basic one.
and just carries it. Uses this line, and then along with the rover we pick up here,
Yeah, with the part that comes off.
and then it comes over here, drops, and then we back up, push it, and then
The arm
and then
comes
it
out.
backs up again and moves the arm and puts it forward.
Yeah.
And then that's it.
Alright, I have one final question. Yeah, I have one question. So, I love all the attachments, they're awesome. I love that you have the ability to do a ton of missions. But how well do they adapt in mold with your robot? I mean, are they difficult to attach? Does it take a long time? Because this is a time game.
Most of, like this one, the hammer time, and also the wall follower we use for the space travel, we have a little peg on the on the bumper that would go into these little holes, and
So
that one.
and then it takes like, for camera time, it takes like 3 to 5 seconds to attach it.
But this
And
one takes.
so most attachments we build to fit with the robot and then perfect them for the mission.
And they stay on fairly well?
They still, we had a few problems with the arms falling off when we finished that.
We spent the majority of our very last meeting making sure that all of our attachments were easy on, easy off, and that we could just get them on and off very quickly.
How did you come up with your engineering process? You have pretty clear one.
Trial and error.
Trial and error, flow charting, like Marcus was saying during, when he was talking about our strategy,
Oh yeah, we looked to see if the missions were easy or hard, which ones were good points, and how close they were to base.
Yeah.
and then we usually, for mechanical, we would look at would it be easier to do a programming thing or a big mechanical design like that.
Thank you guys very much.
Thank you.
Thank you.
Thank you. Thank you.
Thank you.